Good morning and one and all physics students, and welcome to another episode of Physics. It's Mr. Finn coming at you from neighborly Northville here. Hey guys, hope you're having a good week this week. I got a couple things for you today. We're still rolling with those videos I made previously regarding electric circuits and some of the stuff that I did with the regular crew. But I do have a couple of incidental pieces I want to kind of put in there, insert on there along the way, and this is one of those. So I'm going to give you the introduction to power today, show you something real quick on our lab setup, and then let you guys get into the video for today, and of course the Google form that follows later on. But if there's any questions, I hope you guys are keeping up. Please email them in or meet me at the Google Meets and we can discuss. Remember to, obviously we're keeping up with stuff. If you have any issues, please let me know. But you guys have been doing great so far, so I'm really, really proud of you. Doing what you can in this time of very uncertain times. But I really do appreciate what you're doing. So let's get a look at power today. Okay guys, let's take a quick look at power. You'll recall from our first semester that power was actually the energy used or expended per unit of time. And that's still true. No matter what we do in the second semester, the first semester stuff is still good. So, 1 watt is otherwise known as 1 joule per second. So, if I did a certain amount of work in joules in less time, I would actually be using more power. Interesting. But for us, in the second semester, specifically with electricity, power can be seen as current times voltage. Now, you may have come across this already, but our definition of current is the charge flow in coulombs through an area every second. So it's charge divided by time. And you'll recall from earlier that voltage is actually the electric potential energy per unit of charge. So PE subelectrical divided by Q. These units are also shown below. A unit of current is coulombs per second. That's the charge flow per unit of time. And the units of voltage are joules per coulomb. Remember, we had a discussion about PE electrical versus electric potential energy. Not the same thing. So, what happens when you have a coulomb per second and you divide by a joule per coulomb? Well, my friends, you've probably already seen this. The coulombs are going to cancel. And you're simply left with joules per second, as you would be in the energy stuff from the first semester. Or Q per T divided by PE per Q. Well, again, Q's cancel. And you're left with potential energy per unit of time. Just because that potential energy is electrical and not mechanical, it makes no difference. It's still power. Now let me show you the setup that I had going into the video that follows this video. Okay guys, it's a little confusing, but let's see if I can walk it through here. I've got 2 batteries here. I've got a white alligator clip that's connected to nothing. I'm going to put a bulb on that one. From the other side, it goes through this red wire to this black wire, which goes into the meter, out the meter's red wire, into this yellow wire, so I can get a clip on there, and that's connected to nothing. And you can see that right now, my meter is reading 0 milliamps. I have it set to the milliamp scale right there. Now, guys, if I take this round bulb, that's a round bulb, and I place it in here, I'm going to hook it up very carefully. You see that the light goes on. You can also see that we're reading about 199 milliamps. It'll fluctuate a little bit, but it's about 199 milliamps. And please notice the brightness of the bulb. Now, I'm going to take the round bulb out, and I'm going to put in the long bulb. Now, as I put the long bulb in, I wonder what will happen to the current readings on my meter. You can see I'm a little bit brighter. I got a little bit of brightness there, but I'm at 69 milliamps. So we went from 199 with the round bulb to 69 or so with the long bulb. Wonder what's going on there. Now guys, power is current times voltage. I'm going to put the round bulb back, but I'm going to add 2 more alligator clips. They're clipped in here by themselves. All I'm going to do is add them into the system. So remember our piece of resistance video. I'm going to add them into the system. We're going to read again. Remember we had 199 milliamps for the round bulb. What are we reading now? Not 199. Guys, we're reading about 185.6. Notice the brightness of the bulb. It's been changed. We have the same voltage, but we have less current, and therefore we have less power. Let's confirm that relationship by using the other bulb. I don't know if you can see that. A little bit of difference in brightness, but not as much as noticeable. And instead of 65, we're down to about 62 milliamps. Now we're going close to about 58 milliamps. So it's definitely a change. Less power, even though the same voltage, because we have less current. Okay guys, so wrapping up our introduction to power here today. It's current times voltage, but it's still equal to energy per time if you just rearrange those units. I'm hoping you can see in our demonstration, but by adding actual wires to the system, 2 more of our pieces of resistance, we actually lowered the current and in effect lowered the power values as well. Voltage remained the same for all those trials. In the next video, I'll be showing you some differences in power, some alternate ways of looking at it in case you don't have current and voltage. What if you have resistance and voltage? You should still be able to get power. Okay guys, take care and make sure you view the videos and get those Google Forms and labs done and we'll be all set. You've been doing a great job so far, so keep it up. We'll see you next time.